take a look and you guys can follow along. The negative 2y needs to be distributed to each term. So using distributive property, I can rewrite this as negative 2y multiplied by negative y plus negative 2y multiplied by 2. Okay, so I could rewrite this as negative 2 times, well, negative y means negative 1y. So negative 1 times y plus negative 2 times 2 times y. Well, negative times a negative is positive, so I'm going to get 2y squared plus negative 4y. If you write it as 2y minus 4y, or sorry, 2y squared minus 4y, that's fine. They're the same. It doesn't matter what you do. That would be the same. It's just the adding the opposite of one another. So a lot of you, I think, are really comfortable with the modeling. But once you guys start doing the practice, you will, just like the other sections, you'll start to move away and you'll realize that this is okay. You start to see the pattern and we can move away from it. Okay. So we haven't looked at any dividing yet. Okay, so we're going to just take a look at this example. If I give you negative 8s squared plus 6s and I ask you to divide it by negative 2s, just like these examples here, each term must be divided by the negative 2s. Okay, so I'm going to rewrite it so I don't make any mistakes as negative 8s squared divided by negative 2s plus 6s divided by negative 2s. But we probably need to be reminded of something again from chapter 2, because our powers keep coming back into play. If I look at something like this, x to the 4th divided by x squared, we knew that this meant x times x times x times x, and I'm dividing it by x times x. So what can happen with some of these x's in the numerator and the denominator? What can I do with them? I have 4 x's in the numerator and I have 2 x's in the denominator.
Combine them.
I can combine them. How do you combine them though? Yeah, but we're dividing them. So what do we do with those? What happens? What happens when you divide something by itself? What do you do?
What? Cancel?
Yeah, they cancel. So these can cancel each other out. Anything divided by itself is 1. If you multiply something by 1, you just get itself. And then these cancel each other out, and our solution was x squared. But we had a method of going straight from this down here. There was a rule for exponents. What was it? Whenever you're dividing exponents with the same base, what do you do with them, Chris? Yeah, so anything, if you're dividing with the same base, x to the 4th divided by x squared is the same as x to the 4 minus 2, which is x squared. So we're going to use that and apply it. Okay, so if I'm dividing, I've already got it set up. So same thing, I'm going to divide these coefficients. Negative divided by a negative is positive. 8 divided by 2 is 4. S squared divided by s, if I just write an s, it's like s to the 1. So 2 minus 1 is 1. So I'm going to get 4s. Plus, well, 6 divided by negative 2 is negative 3. S divided by s, they cancel each other out. So my solution is 4s plus negative 3. There's one last example on the board. I want you guys to do it. The note is if I draw this like this, or I write it, and this line, which is division, fraction line means division, fraction bar is division, this means that the whole numerator is divided by negative 7c. So each term you have to divide by negative 7c. A lot of you probably would like to rewrite that so you don't forget.